All right, we're just going to kind of start with the kind of the most basic, most generic way of thinking about this. I'm going to just take an expression here, whether it's just x or maybe some coefficient times x, or I'm going to write it. I think maybe your book shows it this way. A lot of times, a lot of textbooks show it that way. Last class, he showed as absolute value of x is equal to some constant. And they use a, but it doesn't really matter. But what we're doing there, absolute value, what did you guys learn? I know you learned in Algebra 1. I know you learned in Geometry. I know you talked about it probably last year. What is absolute value? What does it really mean? What's the definition? Yeah, the distance something is away from 0, right? So what we're really doing here when we solve this absolute value equation is we're trying to solve a value for x that when I plug it back into this expression, it forces this expression to be c units from 0. That makes sense? Okay. So here's the rule that we kind of abide by. If I have ax plus b, that absolute value is equal to c. Okay. The first thing you do is you write the equation ax plus b is equal to c, and you solve that equation. Okay. So ultimately, you just got rid of the absolute value bars, and you solve what's left over, right? Okay. But understand, the thing that is problematic about this question is the absolute value bars. So I can't just get rid of them, solve, and be done, right? If I get rid of them, there's always got to be something that compensates for that, right? You can't just say, well, I got rid of them, I solved this, I'm done. Because if that was the case, they would have never given the absolute value bars to begin with. Does that make sense? They would just give you ax plus b equals c. Okay. But what this does, okay, is it creates, let's say 0 is there, right? Okay. Let's say c is over here. Okay. The value that I find for x is going to give me this expression here to fall in those spots, somewhere in that spot. Does that kind of make sense? Those values there. Okay. Oh, I'm sorry. Not there. It's just going to be there. I was thinking inequalities. Getting ahead of us. That's going to give me that value, whatever x value I find, is going to place this expression c units away from 0. Okay? But we know if I'm starting at 0, I could walk to the right, correct? Could I also walk to the left? So I want to find some x value that will put me over here. Okay? And that's where we get this rule that says ax plus b equals the opposite c. Okay? Now that's going to give me an x value that puts that expression c units to the left of 0. Okay? So we'll do, I know that's kind of generic, general, kind of arbitrary with those values, so we'll do one with some concrete values to kind of make sense of this whole thing. If I've got the absolute value of, let's just go 3x plus 1 is equal to 10. 3x plus 1 is equal to 10. First thing we want to do is realize that we are trying to find a value of x that when I plug it into this expression, it puts that expression 10 units from 0. Okay? So, first thing we're going to do is we're going to go 3x plus 1 is equal to 10. What I want you guys to realize and understand is that when you are on a test or a quiz, and you get to anything that deals with absolute value, if you forget your list of rules for absolute value, hopefully you don't, because you learn the ideas and the concepts, and that doesn't the relationships. So you don't have to memorize all these rules. But if you forget them at some stage, you can at least get half credit by just getting rid of the absolute value bars and solve what's left over. Does that make sense? Because that's all I'm doing here, right? That's half the problem. Got rid of the absolute value bars, just solve what's left over. So that gives me 3x equals 9, x is 3, right? Okay? So what that does is that quantity, x equals 3, puts the expression 3x plus 1, 10 units away from 0. And in this case, because 10 is positive, it's going to be 10 units to the right of 0. Does that make sense? If I plug in 3 to this, you get 3 times 3, which is 9, plus 1, right? What's the absolute value of 10? It's 10, right? Okay. Now, what we want to do is recognize, okay, that moved me to the right of 0. Let's talk about moving to the left of 0. So if I move to the left of 0, again, we started with this. We've already done 3x plus 10 equals, or 3x plus 1 equals 10. Now we're going to go 3x plus 1 is equal to negative 10. Because we understand the idea of absolute value. If I take the absolute value of 10, it gives me 10. If I take the absolute value of negative 10, it still gives me 10, right? Okay? So we have to have that that negative component in here. We go 3x now is equal to negative 11. X then is equal to negative 11 thirds. So x equals negative 11 thirds. We'll put that expression, negative 11 thirds, multiply that by 3, gives me negative 11. Negative 11 plus 1 gives me negative 10, right? What's negative 10? What's the absolute value of negative 10? Still 10, okay? So those are my two solutions for that absolute value question, okay? Now, when I write my solutions, because you have a finite set of solutions, you're going to write them in a list, okay? And usually we use this curly brace to tell us that, hey, we're going to start a list here. And we just put them, it doesn't really matter the order. But we put those two solutions in, and then we close that list off, okay? We call that roster notation. Okay? You know, and roster just means a list of things in my group, right? If I am a manager of a baseball team or something like that, maybe I got my 25 names of my players, and that's my roster, right? We've all heard that, and maybe baseball or softball, basketball, whatever. But you guys are also a roster. Every year I get a roster of my class list. Make sense? And it just has last names of everybody's in my class. Okay? Well, here's it's just a list of things that I'm going to incorporate in my group. The group is just solutions to the original inequality, or not inequality, equation. Those are things that satisfy it, and we write it as a list of objects. And it's finite. Okay, meaning I can count how many solutions I have. Does that make sense? Okay. There might be a million things in there, but that's finite, right? I don't know if we talked about this last week, the blades of grass in the courtyard. A lot of them out there, right? But we can count them, right? We can associate a number with every one of them. All right? There's a finite number of blades of grass out there, okay? There are things, though, that are infinite that we cannot count, and we have to use a different type of notation to show this, okay? So this is roster notation. Understand, if I would write it this way, that changes the complete meaning, right? Now I said there's an infinite number of values here that would work, and they go from negative 11 thirds all the way to 3, not including negative 11 thirds of 3, right? Does that make sense, everybody? So these, though people think it's not a huge deal, those curly braces or parentheses or square brackets tell us a lot about how we read our solutions, what our solutions mean to us, okay? So make sure we're looking at writing it that way. WebAssign kind of eliminates some of that because they either start the curly braces for you or whatever. My concern is, if we don't talk about those things, you're going to get into a college class at some point, and the way you write things is going to be graded. So that a lot of times in college level course, they look at that syntax when you type an answer in, or write an answer by hand. They look at that and say, okay, is that written correctly? I'm going to grade on how it was written. Okay, we'll make sure we understand that. So that is absolute value equations with one absolute value bar, okay, or a group of bars. Okay, if I look at that graphically, again, we talked about how every equation we come across has a graphical representation. Think about what absolute value does. Absolute value, if I had just the line y equals x, okay, the absolute value simply takes your x value, I take its absolute value, and that becomes my y value. Does that make sense? Okay. So we have, in this case, x value of -1. Take its absolute value. What's that give me? +1. So I should have a point right there. X value of -2. Absolute value of it makes it +2, right? So the absolute value function of x looks like that curve. Okay. Where, I don't like that color. Let's say. All right, so we see the relationship between the purple one, which was just the line y equals x, and now the red one, which is the line y equals absolute value of x, right? Simply take the part of the purple line that is below the x-axis, and if you reflect it above the x-axis, don't you get the absolute value? Does that make sense? Okay. So that's what absolute value does, because we understand it takes everything that's negative and forces it to be positive, right? And everything that was positive just stays positive, correct? So that's why we didn't do anything with this side over here in the first quadrant, but the third quadrant stuff got reflected over because they were negative values, so they become positive. Same thing happens when we talk about, I think what was the equation we had? 3x plus 1. So absolute value of 3x plus 1. Okay, is that idea right there? Okay, and that is because we took simply the equation 3x plus 1. That's your equation 3x plus 1, right? That green one. And you see that's going all the way through. Okay, that into the first quadrant, it's passing through that line. All we did was we take that green portion that we see here and reflect it across the x-axis, right? And that gives us that red V. All right. But now when the question is, when does that thing equal 10? Well, the right-hand side of my equation is now 10. Zoom out and get that picture on here. We're interested in those two locations there of the x values of those intersection points. Okay, and we find out that one of those is going to have an x value of 3. Okay, down here, and this x value here, I can't remember. It was 11/3, -11/3, which is -3 2/3. Okay, so that's kind of the visual of what we're doing behind the scenes. Does that kind of make sense? Okay. Is it okay? Is it a bee? Anybody allergic to bees? All right, I don't have any EpiPens. What I want you guys to understand, last class said, I asked the question, I was like, what does the absolute value look like? What does an absolute, graphically in a 2 dimensions, what does absolute value look like? And everybody said V, it looks like a V. And it did, right? Okay? But that's only if your original function was linear. X was linear, so absolute value of x is a V. 3x plus 1 is linear, so absolute value of 3x plus 1 is a V. But if I have something that is nonlinear, let's say x squared plus, let's go minus 3x minus 5. If I have that function right there, that's nonlinear, right? Think about what's going to happen. We'll get into a whole lot more detail about this later. But if I'm thinking about absolute value, just like we did in the last one, the linear things, the y values that are negative all became what? Positive, right? Would we agree that things below the x-axis here are negative? Well, your absolute value function of that then, just go ABS, and you can graph these on your calculator. I'll show you eventually how to graph this on your calculator. But it forces those points that were negative to get reflected and become positive. Now that's the graph of that. Okay? So a quadratic looks like graphs are right. So cubics are going to look different. Okay? See if we can put a third power in here. Okay, so that's what a third power absolute value would kind of look like. Well, what a group of them looks like, not all of them look that way, because not all of them cross the x-axis that way. Okay, some of them might look like kind of like an M or something like that. But what I want you guys to understand, that the V that you have in mind is simply because a lot of times you just focus on just linear expressions. But you can have a quadratic, a cubic. To solve those and deal with the solutions for those is a pretty involved process, and there'll be an entire section devoted to that, maybe 2-3 sections actually devoted to that process. Okay? Right now, everything we deal with should be linear with absolute value. You also saw a question like this. It comes towards the end. Like I have ax plus b, that's the value of that, is equal to the absolute value of maybe cx plus d. You get an absolute value equals an absolute value. And they're just both linear expressions you get on the inside. All that means is you've got that V shape intersecting another V shape. Does that make sense? Okay. And the way you approach this, okay, is that we simply solve that expression there. And that's then saying that ax plus b is equal to cx plus d. It's telling us basically that we're looking at really to the right-hand side maybe of 0 in that situation. Okay, where we're intersecting there. Now, the same idea happens, and then we're going to solve ax plus b. Got to have two ideas here. Normally that was just like an absolute value of, or sorry, that was just a constant in the last question, right? Or the last type of question. Now it's an expression. So instead of multiplying just a constant by a number, or a -1, we're going to multiply that entire expression by a -1. Okay? And those are the two things that you're going to solve. Those are the two equations you're going to solve. Okay? Now, what happens with this one, I'm going to write this in blue. Okay, you could have done this, because it doesn't really matter on what side that negative gets multiplied by. You could have done this. Could have done that. Okay, giving the same results that first one did. Okay, you do not have to do both of those though. Does that make sense? They're gonna yield the same solution. The one thing I want you to understand is that you can't multiply both sides by negative, because if I multiply both sides by negative, doesn't it just give me the same thing that I started with right here? Okay. So we want to make sure that when we're doing absolute value bars, we get rid of the absolute value bars. There has to be a component that we add in. There has to be an extra part that shows up when we got rid of those bars. Okay. So for instance, if I have absolute value of like 2x plus 3 equals absolute value of 5x minus 10. Okay. What we're looking at graphically there would be what I have 2x plus 3, 5x minus 10. Something like that. Okay. And now we're going to be looking for the 2x values that the orange curve and the blue curve intersect at. Okay. And that's what that procedure of setting up basically this expression here, get rid of the absolute value bars. That will give me one of those intersection points. And then doing this opposite idea here, for one of my sides, is going to give me the other intersection point. So, solving this one, I'll go 2x plus 3 equals 5x minus 10. Obviously, an equation we can all solve, right? Okay. 3x equals 13. X is 13/3. 4 1/3. Okay, and then the second portion of this, okay, doing that rule, I'm going to have 2x plus 3. It's equal to, now it's the opposite of this quantity, okay, or that quantity. Okay, so I'm going to rewrite. I'm very deliberate with this because I know I don't want to make a mistake with that negative sign. What happens? A lot of people we'll just put the negative with the 5x. Okay, we'll forget that they have to distribute it. We're going to go 2x plus 3 equals now negative 5x plus 10. We're going to add 5x to both sides, so we get 7x. I'll subtract 3 from both sides, so we get 7. X is 1. Okay, so my two solutions then are 1 and 13/3. And if you go back to the graph here, that x value right there is going to be an x value of 1. And this one right there, we can trace down there, that's about 4 1/3. Okay, so it is. Does that kind of make sense? Okay. So those two types of equations you've seen so far with inequalities, or not inequalities, you say inequalities, equations with absolute value. But now I want to talk briefly about inequalities, and actually, we'll just stop there today.